All right, welcome back. Good work on following the video directions. A lot of you guys that I talked to said it was actually pretty easy. And so we're going to do another video to see what we are going to do for this next one. We are going to be looking at centers. If I did a circle, there is a center, clear center. You guys talked about that since 7th grade. But what we're going to look at today is we're going to look at triangle centers. There are 4 triangle centers that we're going to talk about, and not just one. But this time we're just going to look at 2 of them. And so I'm going to show you guys how to create those, and so that you can manipulate them and answer them. So once you guys are done with this video, or during the video, go ahead and do the 6.2 notes on Go Formative. And then once you're done with both those, you guys can jump on and you can do the 6.2 homework. So the first thing we're going to do is create a triangle. The best way to do it is to grab this polygon tool. So I can hit A, B, C, and go back to A. What's nice about hitting the arrow button is I can now move these points anywhere I want, creating different types of triangles. One thing that we're going to look at is specific types of triangles, so like acute, obtuse, and right triangles. And so what we may want to do is we may want to come down here and hit the angle button. And because I made this nice triangle, all I need to do is just click on the inside and it gives me all the angles. We can grab the arrow and we can move these out so we can see them. And so now I know that this is an obtuse triangle because that angle is greater than 90. I can move that triangle right there. And I now have, let me just fix this so I have an acute triangle where all of them are acute. And then if I wanted to get really crazy, I can do my best to make this a perfect, that's not going to happen. Let's go right there. Make this a perfect 90-degree angle, or at least close as I can get to it. 6, 5, 4, 3, 2, 1. So now it's a right angle, and we can actually talk about stuff being a right angle. So I'm just going to do this. So the first thing we're going to do is we're going to create something for perpendicular bisectors. We're not going to mess around with doing what we've done. We're going to use the GeoGebra Genius. And so down here in construction, we're going to actually just grab this perpendicular bisector. So I'm going to grab that perpendicular bisector, and I'm just going to click on a leg length, and it creates a perpendicular bisector. We know it's a perpendicular bisector. That angle is going to be 90, but then I can also use this distance function to kind of say from C to D and D to C, it's always 4.9, no matter, or not always 4.9, but they're always the same, no matter where I put that. So we did that yesterday. We created a perpendicular bisector. But I'm not only going to do it on that side, I'm going to do it on this side as well. And they intersect. No surprise there. But what's going to be interesting is when I do it on the third side, that it goes through that point. And if you just let your inner nerd out for one moment, just the idea that we didn't create that, we didn't draw, I didn't ask you to draw 3 lines to the same point, it created that. That is pretty cool. This point right here turns out to be pretty special. What this point is called a point of concurrency. A point of concurrency is a point where 3 or more lines intersect. And so it's a special point of concurrency, and it's actually going to be called, I'm writing it out now, a circumcenter. And so a circumcenter is point D, and that is going to be the point that is created by perpendicular bisectors. And so I want you guys to create that, and I'm asking you guys a couple different questions in there. And you can move this around and see that it stays in there. It stays there, it stays D, no matter where we put it, no matter what type of triangle it has, it will always be there. But then the other cool thing, again, I'm saying cool, is that if I take a circle and I put it on D and I go to any of the vertices, look what happens. It's a circle that goes through all those vertices. And so we want to kind of ask, why does it do this? And what we can remember is that on our perpendicular bisector, every point on this every point on this perpendicular bisector is the same distance from these two. So these 2 points, A and C, are the same distance from D. But every point on this perpendicular bisector is the same from C and B. And so it's also the same from there. And so whenever, oh, I don't want to circle. Whenever we move this around, it's going to be inside there, and it'll always, that point D, the circumcenter, will always be the same distance from the vertices. So what I want you guys to do is I want you to go on and try to create a circumcenter. You don't need to do the circle, but just to create it and be comfortable with it. I will now get a new screen and then create the other one. And I'm going to do the same thing. I'm going to create a triangle, ABC, go back there. But now instead of perpendicular bisectors, I'm going to do an angle bisector. So it says select 3 points or 2 lines. So I just want to find this one and this one. It has these 3 lines out here. I don't care about those. This is the one we care about. And then I'm going to cut this angle in half. So we have an intersection, and it looks like it might do the same thing, when in fact it does. This point right here is another point of concurrency. And as I move this around, you see it stays there no matter where I move it. But what this point is called is the incenter. So it's a different center. So right now we have 2 centers of circles. And these centers are very special in different ways. What we are going to notice about the incenter is it's clearly not the same distance from each vertex. But that's not what the incenter says, right? The incenter is created by angle bisectors. And as long as I have a point on an angle bisector, that point is always going to be the same distance away from these 2 sides. So this point right here, D, is the same distance away from these 2 sides. And this point, again, D, is the same distance away from these 2 sides. So this is the point that is the same distance away from the sides of the triangle. And we can actually see that if we go ahead and we click on D to here, 2.4, D to here, 2.4, D to here, 2.4. Now the important thing in here is remembering that the distance has to be a perpendicular distance. So I could go ahead and I could create a perpendicular line through here, and I could see that point. And what we're really measuring is we're measuring the distance from D to F as being 2.4. So that's one way to look at it. So I want you guys to create those 2. Watch the first one, create it, come back, watch the second one, and then go through and answer the notes and the homework. I am hoping to have some more to be on Google Meet again later on today. And so you guys can come on and ask me questions. But so far, I think we're doing okay. There's just a couple people I haven't talked to. Other than that, I hope you guys are doing well. I miss seeing you guys, and I will talk to you soon.